So let's make a video about knocking around some enemies. We left off with the blobs chasing after us, but unable to hurt us and unable to be attacked. So let's try to make it so that we can actually knock these blobs around with the sword and eventually defeat them. So we're going to have to make a few tweaks and changes to a couple of things here in order to achieve that. And I think the best place to start would really be our weapons. What we want to do is put some stats on our weapons that deal with combat. So I'll start with the object melee parent and go to the variable definitions here. And we've got, oh, hi kitty. We've got some stats about just functionality, but no stats about actually damaging things. So let's put in some stats for that. So we're going to need a couple new variables. So first up, and I'm going to give these a prefix of stat. So this is kind of like the weapon's stats. First up, damage. Seems pretty self-explanatory, but you know, we need some damage on these things. Next up is the knockback strength. So stat knockback. And this is a pretty tough variable to get right. 15 is going to be pretty high, honestly, but we can always tweak it. Then we want a stun time. So how long does the enemy get stunned for when they get hit by this weapon? Now, right now, all of my weapons are going to inherit these same values. And if you wanted to tweak them so axes deal more damage than swords, or spears don't stun for as long and have less knockback, feel free to adjust them to whatever balance you think makes the most sense. I'm going to leave these as just vanilla inheritance. The arrow needs one. So we're going to need to also add the same traits here. We need damage, knockback, and stun time. So we're going to add stat damage. We can make this, I guess if I'm trying to really balance this, we'll just make it 10 as well. Then we need a knockback. And this isn't as extreme, so I'll just go for 10. And we need a stun time. And I'm going to make this less of a stun, so just 20. Now, since the arrow had that unique charging effect, if you feel like tweaking these values, we could go into the bow, actually, not the arrow. And we could make the bow modify these based on how long we charged. So if we go to the bow and the begin step, this is where we were charging up with the mouse, and right here is where we're going to spawn the arrow. We could take and modify these variables we could either reuse that same formula that we used before, or we could just do like a linear modification. So we could just do a linear modification to this. So we could say arrow.stat damage equals, I think we can get away using times equals here. Times equals charge divided by charge max. And so this would give you a ratio that if you max out the charge, you will deal full damage. Or we could be a little bit creative here and maybe make it so that we add a tiny bit of bonus to it, so that if you charge for long enough, you could go over that default of 10. Since I think the charge is either 60 or 30. So 60. So it would have let us go up to 70 over 6. So like, I don't know, 14, 13% extra damage. So we could just go through and do that. Arrow, stat, knockback, times equals. So we're just going to do this linear formula. Arrow dot stat stun time. So if you don't charge the bow, you don't get a lot of damage or knockback on it. Okay. So we've added some stats to our weapons to be able to start attacking the enemies. So next up, we're going to have to build a little bit of infrastructure in our code to be able to support attacking the enemies. So we're going to need a new script to do this. Actually, technically two, but let's just start with knockback. We're going to want to do a hit flash script and a knockback script. So first up, let's make a new script called scr underscore movement underscore knockback. And this script is going to be the script that we're going to use to handle getting slid around due to the knockback of the weapon. I want it to be different from the move script because this is meant to be handled kind of separately, but there's still going to be a lot of similarities. So first up, I deleted that SCR in front of here, so in case you missed that, and I know that that's one of the more commonly missed little tweaks that I do. So first up, we have the stats for our movement knockback stored on our players. I want to vectorize that because the parts of this work a little bit better with this as just kind of vectorized. So like when I start applying friction, that works to here. So that would be var move knockback direction. And you could, there's actually a built-in formula to do this. We don't have to pull out our trigonometry skills. Just point direction from 0, 0 to move underscore knockback underscore x. So basically any actor that's running this script will need to have those knockback variables. Those are actually the only extra movements. Oh, and I think we use move friction. So knockback X, move knockback Y, move friction, and we do use that impassable objects array. All right, so back to the vectorization. So move underscore knockback magnitude. So the magnitude of this is just the Pythagorean theorem. So I don't think there's a built-in method for this. So it's the square root of, is power a thing? Oh, we do have power. 1 to 2 power. Of move knockback x squared plus move knockback y squared. So the vectorization is useful for when we start applying friction. Then apply the knockback move. And actually the applying of this is done through the move and collide method. And we plug in the x and the y amount. So I'm actually putting it first just because we don't need to do that computation right away. It actually uses the componentized vector data. And then the things that we want to avoid are the impassable objects. I don't know if I spelled that right. There we go. So we move and collide. Then we're going to vectorize these components. Then we're going to apply friction to slow us down. And that's so that if we're on ice or something with less friction, we slide further. So we're going to get the magnitude of my knockback. And if the magnitude is greater than 0, then we want to apply, essentially pulling this value towards 0. And so the math formula for that is move knockback magnitude is going to be set equal to the max of taking the absolute value of the movement knockback magnitude minus the friction, or 0. So the idea is that by subtracting friction, we could potentially go negative. If we applied enough friction to stop us, this would be negative, but we are going to take the max of that. And so the max of a negative number in 0 would be 0. Otherwise, if we still have movement left, it's going to choose the amount of movement. And then we'll multiply this by the sign of the movement magnitude. So that keeps it going in the same direction. If for some reason magnitude became negative, we keep it negative. So then we'll just go back to rectangular components. So because that's how we're storing this. So move knockback x is going to be set equal to length direction of move knockback magnitude, comma move knockback direction. And we do the same for y. If this doesn't make sense, you might need to just review how vector componentization works. This is just some vector math. And I actually don't know if GameMaker has a more built-in way to do this that might be more efficient, because I can definitely say that from a processor computation standpoint, the more powers in the squaring and the square root you do, the less efficient it gets. But the counterpoint to that is we're not going to have like millions of enemies on screen. If we were trying to do like a horde game where you fought like 1,000 blobs simultaneously, this would not be a good idea. But since our game is going to have maybe 10 blobs on an entire sector of a map, we have the processor power to spare for this. So yeah, if you were doing a horde game, rethink this. All right, so that looks good for our script. So now we need to recognize when an enemy gets hit by a weapon. So we're going to go to our enemy parent. We're going to handle this inside the parent. So we want to deal with a collision with a object melee parent. So all of the melee weapons will be covered by this. So this is hit by melee weapon. So here's where we're going to use that list that we created right here, this already hit list that we made in the previous video. What this list is going to do is remember the IDs of any objects that have hit it, and we're going to check that list to see if that object has already hit us. If we don't do this, the sword, when it's swinging, could hit the same blob like a million times. It'll actually hit the blob every frame. And we don't want to hit the blob like 13 times per attack animation. We only want to hit the blob once per attack animation. So that's what we're doing here, is we're restricting it to only one hit per instance of that thing spawned. So if ds list find index of the list already hit, and other dot ID. If that is equal to -1, then we have not been hit yet. So if this enemy has not been hit by that weapon yet, that's what this means. Find index is like index of from Java. It returns -1 if it doesn't find it. Otherwise, it returns the index of where it was in the list. And lists start at 0. So not being found is -1. So let's get the angle to the weapon. So this is coming from the weapon's point of view, and this makes the vector of how we're going to get hit. So var angle equals point direction other.x other.y, x and y. Then that gets us the direction. Now we want to basically componentize this and store that into the move knockback vectors. So get the component, the vector components of the knockback. I'll draw an MS Paint diagram after we write the code to explain what's going on here. So move knockback plus equals, so we can have multiple things knocking us back. Length direction x, other dot knockback, stat dot knockback, comma angle. And then we're going to do the same for y. So this will be y. All right, so I promised an MS Paint diagram, and so I know everybody's favorite thing is when I pull out MS Paint. So here's what's going on. To explain this code and what we're doing with this. So if the blob is right here, and my sword hits it, let's say that the player is right here, and my sword just hit the blob right here. So what we're doing, and remember, the blob's point is here, the sword's point of origin is here. So when we do this command called angle, and we get point direction from the weapon to the blob, that's getting a vector. It's getting this angle. It's not really truly a vector because we're really just getting like that direction. So angle is going to represent this blue line. Then the knockback stat is going to be how far this blob is going to be knocked back here. So the length of this vector is the knockback stat, and it's set to the angle that we just got hit from. Then we componentize it. So the componentization is getting this part. This is the x component, and then it's getting this part, which is the y component, so that we can store the movements as an x and y amount. So that's what's happening. So the end result is that the blob will slide in the direction we smacked it, or the direction from the player to the blob. I know, I should have saved that wonderful work of art. So apply effects. So the effects that we want to apply are hit point damage. So we're going to say stats HP minus equal other.stat damage. So each weapon that we could get hit by has a damage on it. Apply stun and hurt So the hurt is going to be used for animation. So stat stunned. So here's the decision we have to make. Do we stack the stunning effects or do we override the stunning effects? So I think we should just override, because I think if you stack stunning effects, you're setting up for some bad game design. So the stun effect is going to be the max of the current amount of stun that you have and the amount that the weapon is attempting to apply. So if this, like, let's say you were hit by a spell that stuns you for 5 seconds, and then I hit you with the sword that only stuns you for half a second. We shouldn't replace that 5-second stun with the sword's really junky stun. We should still let the bigger stun persist. So that's why we're choosing the max of these two. So if you're already stunned for a bigger amount of time, this isn't going to affect you. Because if the weapon's stun stat is inferior to what's already stunning you. And we're going to do the same thing for hurt. If you're already inside of a hurt animation that's longer than what this weapon would have applied. And I'm just using the stun time for the hurt animation. So if you're in a hurt animation for longer, we'll just take the max of those. Then make the monster super aggroed. So this is AI super aggro is true. So it will chase you from anywhere. If you hit a blob from across the screen, it now will not stop until it gets a swing at you. And then the rest of this is going to be animation stuff. We'll put it here, just knowing that we're going to come back to this. So, well, we'll just put to do cancel attack states. So if we were about to attack, there's some lines that we'll put in for here. And then we want to log the ID of the weapon that hit us inside of DS, data structure list. So list.add into the already hit list, the ID of the weapon that hit us. So that's going to be all the stuff that we need. Now, I don't have a good parent setup system for the arrow, so I'm just going to duplicate this. And I cringe as I do this because I would have rather just kind of parented all of this together. But if I had a projectile parent, I would just do that. And I will switch this to a projectile parent if I added more projectiles. But right now, you know, this is the only one we have. But otherwise, it's the same code. It's the same exact stuff. So it could have been inherited. So let's kind of add on to some of what the player was doing. Well, no, we can do that later. All right, so I think, we just need to apply the movement of the knockback to our creature. So in step where we apply our move, so we apply our move, now we want to apply our knockback movement. So we would say movement, knockback, and that will trigger the usage of that method. Well, and we should just test this, and then we'll worry about trying to get the hurt animation to play. Then we need to add end step to reduce the stun timer. So reduce timers and check health. So reduce timers reduct timers. So we'll say if stunned is greater than 0, then stunned, stat stunned, will be set equal to the max of stunned minus 1 and 0. Then if stat hurts is greater than 0, we'll do the same exact thing. Stat hurts is set to the max of stat hurt minus 1 or 0. That keeps it from going negative. I mean, I don't think we really care if stunned or hurt is negative, but it's a little bit cleaner. And then we need to make the enemy disappear upon death. So if hit points are less than or equal to 0, and we are not already slain, then a few things need to happen. We need to set our state to slain. So that would like prevent movement, that would prevent attacking. So like when a monster is slain, it's no longer able to do stuff. And we would have to play animations. And so that would be something that we would want to eventually explore a little bit more. So at this point, we should be able to swat around our blobs. So if we hit play, we can hope that it works. Oh, no. Knockback is missing some stuff. Oh. Oh. The closing parenthesis for max, I believe, should have been there. Oh, the sign function. Oop, we've got an error. So HP is not set before reading it in Blob. So, oh, it's probably stats HP. That's probably what it was. Yeah, I feel like putting stat in front of it really just kind of broke my brain. I was just trying to make my variables organized. It's my only crime here. All right, so now we have functionality. So let's go poke a blob. So we can smack them, they slide back, and there's a little bit of a stun going on there. This guy just ran out of health, so that's why he stopped moving. So we can knock them back, we can use other weapons, poke, poke. Oh, we need to fix this little problem here. So if I get out of its, if I manage to get out of its aggro radius. Oh, it's super aggroed. So we need to, so we won't be able to fix that until we attack. Because I wanted to turn off super aggro after the monster got a chance to attack you. So it is going to chase us relentlessly if we've hit it. And that's just to prevent bow cheese. So that super aggro is to prevent this. So like if you pick up the bow and then you proceed to shoot the monster from all the way over, we want it to chase you until it gets close enough to hit you, then we'll turn off super aggro. But do you see how it jiggles? That's actually a pretty easy and a pretty quick fix. So we could do that real quick. So inside of begin step, all we've really got to do is after we're done with our big if statement, we would just check to see if the target is too close, just be happy and stop. So if the point distance from the monster's X and Y to the target X and Y is less than or equal to the maximum amount of move. So remember, monsters and stuff don't stop instantly. They have the friction and stuff, so even if it stops moving, it still might glide over and it will miss. So it's easier just to say that if you're really close to where you want to be, don't worry about being on your exact position. Just get close enough and call it good. So that this will also prevent that jiggling behavior that the slimes were having. Oops. Again, I'm always forgetting my prefixes. I try to make my code self-commenting, but it tends to just foil me more often than not. So, aggro the blob. Oh, oops. I made that same mistake again. I always make that mistake. So I need to close the parentheses for point distance there and check to see if that's less than move max. See, my cats are sad about that coding error. They expected more from me. And so when I get away from it, it's going to return back to its position, but notice it no longer jiggles like it used to. And even when it hunts me down, once it's close enough, it's happy. It's not going to keep on jiggling. And so we kind of have to decide if we do want the player and monster to not impact onto each other. I'm fine with the player being able to walk through stuff. Maybe we don't want the player to walk through it. So if walking through enemies does concern you, if it concerns my cats, which it does, we could add the enemy to here. That way you can't walk through the blob. However, it needs to be a two-way street. Because if I just make it for the player, we get kind of stuck. We get trapped inside of here and we can't get out. So it kind of needs to be like a two-way street. But we end up with kind of like a pushing behavior, if that's the case. And so, I mean, this is probably fine. So now we can't walk through each other. So you can get blocked by a slime, which I think might be better gameplay to get body blocked by a slime. Because then if you have multiple slimes on you, we probably need to make the slimes not pass through each other. I'm kind of glad that I did this. Now here's an interesting problem, I think. I wonder if it's going to get mad at its own self. I actually am not sure if it's going to get mad at itself. No, that's fine. Ah. And so now I've got like a wall of slimes. And so if you get too many enemies on you, that's going to be difficult for the player to get around. Because you could get trapped in things. So like now I'm trapped in this corner until I like smack them away. Okay, so we've got the monsters chasing us, and I think that's a really good starting point. So I think what we will do in the next video is we will clean up this hitting. So we're going to implement some animation to it. We will put a hit flash. When we hit the monster, we'll add a defeat animation. And then after that, we'll move on to getting the blob to attack us. And then that will kind of wrap up the blob. Then we can move on to like putting in like a skeleton that makes a ranged attack or something. So thanks for watching, and I hope I see you in the next video.